Hello everyone and welcome to another video on how to use trigonometry. In this case we're just going to do a couple of examples of how to solve for missing sides and angles when we have to use sine law. So it becomes more difficult once you're not sure which law to use, so that's something you're going to have to work on yourself with lots of practice and experience. In this case I'm telling you right away that we're going to use sine law, which makes it quite a bit easier. Now, one thing we have to remember from sine law is that we're going to need matching sides and angles. We always need a match. And in this case, you see, we know angle P, but we don't know side P. We know angle L, but we don't know side L. And we know side K, but we don't know angle K. And so because of that, it looks like we can't use sine law. But what you should always do is fill in information that you know from any other source. So for example, we can find angle K right away. Okay, we know that K is going to equal 180 degrees because all triangles have an interior sum of interior angles of 180 degrees, but 66 and 52 of it have already been used up. So 66 degrees minus 52 degrees. We'll do this in a couple of steps. 180 degrees, that's going to be 118 degrees, which is going to be 62 degrees. Okay, so let's just put 62 degrees in here. Well, now we do have a match. We know angle K and we know side K. Also really useful to label all your sides and angles so that you can write out sine law really easily. So we're after a side, and so the form of sine law that we're going to use is the one with the side lengths on top. Sine law is really easy to remember because it's just about matches. So little p over sine big P is equal to little l over sine big L, which is equal to little k over sine big K. And now we have to decide which two we're going to use. Well, we don't really have enough information about L. We don't have a match, so we're not going to use L. So we can simplify this law to just P over sine P is equal to K over sine K. Now we're just going to make our substitutions. So we have P over sine, and I'll put those substitutions in red in this case. So sine 52 degrees, because that's the value of the angle P, is equal to side K, which is 2.5, over, I guess I didn't do my substitution in red. Let's keep it consistent. So 2.5 over sine of the angle K, which we just solved for, which is 62 degrees. Now, where you go from here depends on your comfort. Okay, you could just plug in your calculator what sine 52 is and write that value in instead of that sine 52. You could do the same over here. Instead of writing sine 62, you could plug that in your calculator, write out the decimal number that you get when you do that, then do the division here, then multiply both sides by whatever this number ends up being. And that's just fine. You can do that. What I'm going to do is I'm just going to multiply both sides by sine 52. So I'm going to end up with 2.5 sine 52, because the sine 52 on the left is going to cancel out over sine 62 degrees. Okay, then you can do this all in one shot. 2.5 times sine 52 equals, in your calculator, divided by sine 62 degrees, and you get the right answer. And so I'm going to do that all in one shot. So I just have to remember what the numbers are, 2.5, 52, and 62. See if I remember those. And I'll go over to my calculator we've been using. Nope, I've already forgotten, I think. Well, let's see. So 2.5 times sine 52 over sine 62. Let's see if I remembered. 22.31. 52 over 6. Oh, it should have been 2.5, right? Let's see if we can make a correction on this. Yep, 2.23. I did remember. So this ends up being 2.23. And we started in kilometers, so we end in kilometers. And there you go. That's all you have to do in order to find a missing side. So let's review again what we did. We searched for the missing angle because we already knew two angles. You might as well find that one. So we just did 180 minus the other two angles, gave us the missing angle. Then what we did was we wrote out sine law with the sides on the top because we were after a side. We got rid of L because we didn't know what side L was, so it wasn't a match. So we could use K, the match for K, to find what side L is if we wanted to, but we were after side P. So we got rid of L. So these are our two expressions that are left over. That makes the equation. We just plug in our knowns. So P over sine 52, because angle P is 52, 2.5 over sine 62. Then we multiplied both sides by sine 52 to eliminate the sine 52 on this side. So we did this. That left us that expression, which we just evaluated in our calculator. Again, you could do this as 2.5 times whatever that number is, divided by that number. Then put these together and do the division. You would have ended up with the same number. So that's how you find a missing side. So let's go over here and we'll look for something that we need to find a missing angle for. We got to decide which angle we're after. Oftentimes these questions ask you to solve for everything that's missing, which you could easily do once you find one of them. You just keep going. So let's just find angle V. Okay. So what I'm going to do is I'm going to go ahead and label my triangle. So this is angle V. So this is little v. Big U, little u. Big T, little t. And it's important you label them because that's how we use sine law, right? So I'm just going to look. Can I find anything? Can I find an angle? No, because you need to know two angles to find the other missing one. And we can't use Pythagorean theorem to find a missing side because it's not a right triangle. So I'm going to remember that I'm after this angle here. I'm just going to write out my sine law. So sine u over u is equal to sine v over v. Notice I'm putting the signs on top this time because I know I'm going to try to find an angle. Okay, so the angles are all on top. Well, which set do we know as a pair? Well, we know side t and angle t. So this one's definitely going to be included. Okay, so we don't know anything about u at all. We don't know the side or the angle, so that one's out. So here's our overall choice for expression right there. Okay, so let's write that out again. Sine v over little v is equal to sine t over little t. Then we make our substitutions. So sine v over, try to remember to do this in red, 11.1 is equal to sine angle t, which is 31 degrees. Notice I'm careful to always put the degree symbol in. Oh, switch to red again. So side t is 5.8. And just to simplify this, again, you could evaluate what sine 31 is, write that in as a number, then do the division, solve like a normal equation. I like doing it all in one go. So I've got sine v is equal to, I'm just multiplying both sides by 11.1, sine 31 degrees divided by 5.8. So 11.1 times sine 31 over 5.8. So again, I'm just going to evaluate that. See how well I'm going to remember. So 11.1 times sine 31 degrees over, see, now I don't remember, so I messed up. Sine 31 over 5.8. So let's see. Sine 31 over 5.8 is equal to 0.9856. 9856. So sine v is equal to 0.9856. Now some people, they have trouble because they forget what we're after. This is the opposite divided by the hypotenuse for an angle v. We don't want that. We want the actual angle v. So in order to do that, you need to use the inverse sign now. Inverse of 0.9856. That's what angle v is going to be. So let's go back to our calculator and do that. So now we're going to do, and I'm going to cheat a little bit here. I'm just going to do sine inverse of whatever the result of that is. Okay. Oh. Not sure what's happening here. So let's just get rid of that. So the sine inverse of 0.9856 is going to give us, let's try that again, last time, sine inverse of 0.9856. 80 degrees. Let's go back here. So V is equal to 80 degrees. Okay, so that's how you find a missing angle. So the only difference really is that when you start, you need to start with the sine on top. If you didn't, you'd just have a harder time doing the math a bit later. Okay, label your sides, plug in the values you know. If you got confused over here, remember all I did was I multiplied both sides by 11.1. That canceled that out. We got this expression here, which again you could just do as 11.1. Evaluate what sine 31 is, put that number there, and then divide whatever 11.1 times that number is, divided by 5.8. You'll get this number. Then use the inverse sign to transfer over to the actual angle that we're trying to find. And that's all there is in order to find missing sides and angles with sine law. Good luck with your problems.